We're here at SlatorCon London with Ollie Stott, Language Weaver Product Manager at RWS, and Tom Kocmi, Staff Researcher at Cohere. Thank you so much for joining us today.
Thank you for having us.
you.
So today at SlatorCon, you talked about Language Weaver Pro, the enterprise translation model that you developed together. For those unable to attend, can you please tell us a little bit about how you built the model and what led you to build it?
Yeah, I think firstly on what led us to build it in the first place is, the market has shifted, or the industry has shifted at least, where MT is now done with large language models. That's the frontier now for machine translation. But in this shift, it's introduced these new challenges, and a big thing is new risk as well for our customers. And so when we were defining, what we needed to do and why we needed to build this, essentially what we said is let's identify which barriers we really need to break down. So we really found 4 problems that we needed to address, and we treated them as barriers. And then we said, let's try and break down each one of these barriers. And once that's done, we're ready for general availability. And then on the how, maybe Kocmi is a better place to...
Right.
Yeah.
So building such a model is not an easy feat. We actually talk at the presentation to break it down into 6 main pillars that we focused on. And I would just maybe mention 2 main critical ones. One is having a really strong foundation model, and it needs to be multilingual. So the tokenizer is also set up for the task, which we are well placed with Cohere, where we can build our own foundation model. And the second part, and that's probably the biggest shift in the whole field, is that the data doesn't need to be just high quality. They need to be also high difficulty. If the data are too easy, the model will not learn anything from them. It's basically useless compute on them. So I would say that these are the 2 main messages.
Well, that's very interesting. And from a business perspective, what is sort of the key value that you bring into your enterprise clients with your model?
Yeah, so I spoke about the 4 challenges, right? The 4 barriers, and we identified these in the talk earlier. But essentially the first barrier that we had was quality, or the consistency of it. So we saw that in this move to LLMs now, the quality can be very, very good on the high resource languages. But once you go beyond English to French into non-Latin languages, or where English isn't even involved at all, the quality can drop off quite quickly. But also a really big thing, and it's a really big theme for us in that talk, is that LLMs can produce outputs that can be really, really fluent, but also just completely wrong. And that's essentially just a hallucination. So that's a really big impact for quality that we really need to address. And these are risks that the customer takes on too. The second one we saw was scale. So scale, LLMs famously been known to be quite slow compared to neural models. So if you're going to bring this level of quality to customers, can you meet the throughput requirements as well? So that was the second barrier that we really need to address. But we also identified 2 different ways of scale, or 2 different styles of scale, essentially. One scaling up, which is kind of doing more faster. And the other one is scaling down, so doing more with less. So another challenge that businesses have is they're trying to run these things locally, or with strict data sovereignty and residency requirements. Then they're trying to run this on their own hardware. And models that are typically of this caliber, they require sometimes an entire data center to run. And so that's just not feasible, essentially. And so we were trying to distill this model down to 2 GPUs, which is something we managed to do. And therefore, it's actually feasible to run this on premises as well. So then we can say, okay, there's actually the flexibility of deployment. You can run this in the cloud, or you can run this on your premises, or completely air-gapped, for example. So we have that flexible deployment options for enterprises now. The third one we have was security, and it kind of feeds quite nicely back into the previous one, is that, okay, again, if you really wanted to get this level of quality before, then really you're reaching out to the foundational models, and then you have to connect to their API, and you work on basically their terms. But with this model that we have now, essentially you can run this on your premises, so you can run it on your terms,
right?
Which is a nice thing. So again, those are the 3 first barriers that we've been able to break down. And then the last one was safety. And this is like a big, not a new one, but it's definitely a bigger challenge today than it used to be. Previously, safety kind of just meant something like, let's remove bias from the models. We have to make sure that bias is not in the models before we push it to production. It was a big deal, but obviously it was a smaller challenge back then. Now safety is something like we have to actually make sure the model is doing what it's supposed to do, and not just making stuff up, and also not kind of going crazy and saying things that are potentially harmful as well. And so for safety, we said, okay, and this is specific to translation LLMs as well, because we see these problems get released or get exposed in translation more than just a standard requirement when you're doing coding, for example. So I identified 4 types of overgenerations that we see in translation. The first one we call oscillatory, which is essentially neural babble of old, where word or phrase gets repeated over and over and over again. That's an easy one. That's clearly an error. We can identify those. We then have detached over generations. Detached over generations is essentially when the model is just producing something that it's not supposed to. It's completely detached from the input. So this could be something like where there's some sensitive content in the, or a sensitive topic in the input that the model doesn't want to talk about it, and so it will refuse. Or it could be like where there's instructions derived from the original input. So we're asking it to translate, just so happens that the thing being translated contains an instruction. Typical models will actually follow that instruction and therefore do this instruction and not do the translation, which is what we're trying to get it to do. So the third one that we have then is partially detached over generations. And these ones are pretty common, really. And again, this is where you get the output that you wanted, but actually you just get some extra stuff that you didn't want. And the classic one that we see is, sure, the translation for this in French is, and then you get your translation. And so there's just this unwanted stuff that we need to get rid of. And finally, we have minimally detached over generations. And this is where it's, typically pretty harmless. It's just some additional words added here and there to improve the fluency of the sentence. But the problem is, especially in localization use cases, if there's a post editor working there within guidelines, then this stuff is kind of annoying because you have to remove these things. And actually what we've seen is that in these cases, when these hallucinations or overgenerations are produced, it can actually increase time in post editing, not decrease it when you're using this kind of AI. And so all of these things combine, these kind of four barriers that we identified, these were the challenges and risks that businesses are facing. And by essentially having something where we can remove those barriers, and on the last piece, we have something which we call hallucination detection. So we identify those hallucinations when they're being output by the model, and we remove them from the output before it reaches the user. So that last one on safety is essentially about removing those kinds of hallucinations. And therefore, that's our idea of removing all four of those barriers and bringing this model to our customers. And so it's a really genuinely then enterprise-ready model for translation.
Wow, that's so interesting. And I mean, you've been testing the model in two highly specialized domains, so IT electronics and high-end marketing. So what specific challenges did this domain present, and how did you work to solve them?
Yeah, firstly, so on IT and electronics, it's essentially something that we considered to be quite a bit easier, actually. So on IT and electronics, this data is very structured, very factual, and there's generally little room for interpretation. But it's also a really, really common one for localization, right? And so we needed to see how well the model performed on this, because this is a really common use case. Fortunately, we saw the model perform pretty well on this one. And then the second one we identified was high-end marketing. And on high-end marketing is essentially the opposite end of the spectrum. So this stuff is hard because it's nuanced and it can contain things like humor, and all these sorts of difficulties and complexities get involved with high-end marketing. So we tested on that one again. Fortunately, we saw that it performed pretty well. So we're really satisfied with the performance. But this kind of evaluations was all really ran on once the model was produced, ensuring that it's really ready for us to go to general availability. But there's lots more evaluations that we need to run in producing the model.
Yeah, exactly. So one of the points when we've been building the model, we didn't know what will be the final model, domains that we will be tested on. And that was on purpose because during the development, we have various metrics. And if we would have these domains in there, we could accidentally over-climb on them and actually have a super strong model on these two domains and would be completely useless in real world usage. So it was up until the end of the development that we didn't know about these domains, and we instead focused on our internal evaluation, where the main criteria was difficulty and challenging of the data set. So we specifically designed hard data set that cover examples that modern MT systems actually still struggle on, where we still get the strong signal that our improvements are actually real and not just because we are hill climbing some of the metrics. And this helped us to build a state-of-the-art model that then later being confirmed with human evaluation and all of these aspects.
Awesome. And what are your plans for the future in terms of collaboration and continuing to improve the model?
Yeah, it's a really exciting time right now, I think, with RWS and Cohere in this partnership. We've got our R&D teams working really closely together, and it's really great to see, the excitement that's being brought to both teams in this partnership. The first thing I think the kind of immediate goals is these instruction following capabilities. So it's not just about translation, but actually, okay, a custom has their own terminology, translation memories, style guides, all these sorts of things. Can we try and bring those in to leverage them in the outputs? And so we do have a couple of releases coming up actually, which is really focused on these things and getting the model to follow instructions around a customer's brand guidelines and these sorts of things. But beyond that as well, we're looking at going to more and more languages. So currently today we started on 45 languages. We've already expanded beyond that slightly into different flavors of languages. And we're looking at taking that further. We really want to get into the low resource languages as well.
Thank you so much. It was so interesting, and we are all really looking forward to seeing your newest developments going forward. Thank you.
Thank you.
Thank you.